Hey everybody, this is Miss Eisencraft with Unit 2, More Solving Systems Help. Okay, so we have 4 more systems. We have to decide today if we should use substitution or elimination and then just kind of execute the whole problem. So this first problem is 3x minus 7y equals negative 14 and x equals 2y minus 3. This one looks like a good candidate for substitution. I know that because this bottom equation has the variable x isolated or a variable isolated. So that means I could replace this expression, 2y minus 3, in place of x up here and only have one variable to deal with. So I'm going to rewrite the top equation, and in place of x, I'm going to write 2y minus 3. So that's where the word substitution comes in. And now it's possible to solve because I only have one variable. So I need to distribute. So I have 6y minus 9 minus 7y equals negative 14. We need to combine like terms. Those go together. Negative 1y minus 9 equals negative 14. Now it's ready to solve. Add 9 to both sides. Negative 1y equals negative 5. Divide by negative 1. And I get y equals positive 5. So I'm going to come up here and start keeping track of my solution. I just got y is 5. So now now that I have the y, I need to figure out the x. I could use either equation, but the bottom equation already has x isolated, so it'll be easier to find x using the bottom equation. So my next step, find x. Either equation will do. Okay, so you might want to think through it. X is already isolated here, so all I'll have to do is plug the 5 in and do the math over here. I won't have to do any moving around. X equals 2 times y, which we got as 5 minus 3. X equals 10 minus 3. X equals 7. Okay, so to verify, I could plug them both back into both equations, make sure it works out. I could also type these into Desmos, make sure the intersection is at 7, 5. Okay, next problem. This one does not look like a candidate for substitution because I don't have x equals or y equals alone. Both the variables are on the left here. So let's look for elimination. I'm looking to see if I can eliminate a set of, some variables. So the variables are either the x terms or the y terms. So I'm looking for opposites. A negative 8y and a positive 8y, if I add those up, those will disappear, and then that will allow me just to solve for x. So this is a good candidate for elimination. I'm going to add because my y terms are opposite, and then when I add them, these will disappear. So I have negative 1x plus positive 2x. That just makes 1x, or just x when you add those up. So this was super easy because normally you have a number in front of x and you have to do another step where you divide, but since it added up to 1x, we're good. Okay, so now that I found x, I can plug it into either of the equations. I'm going to deal with the bottom equation so I don't have any of the negatives to deal with. Like up here, there's a negative. So now I found x, now I need to find y. I think I might have said that backwards. Sorry. To find y, now that I know x, I'm going to plug in Miss Eisencraft. I'm going to plug in 6 for my x value. Okay, and then I'm going to work it out and solve it for y. So I have 12 plus 8y equals 36. Now we get to solving it. So much fun. 8y equals 24. And that is y equals 3. Again, I could plug in 6, 3 into both equations, make sure it makes negative 30 in the top, make sure it makes 36 in the bottom, or graph them both, make sure they intersect at 6, 3. Next problem. Another good candidate for elimination, I can see because the x and y's are both on one side of the equation, neither of them have x or y isolated. However, we need to do this intermediate step because right now when we add, neither of the variable terms will be eliminated. So this is where you have to kind of think ahead and go, okay, look at your x's. Would it be possible to multiply one of the x terms to make it opposite of the other? So if this is negative 6x, we could multiply this top term by 3, so it's at positive 6x. So you can do that, but in order to multiply this by 3 and keep this equation equivalent, you have to multiply the whole equation by 3. So I'm going to show that like this, multiply the whole equation by 3. Kind of hard to see with this pen. So if I triple the whole equation, I have an equivalent equation. Okay. The bottom equation, I don't need to change at all. So I'm just going to copy it underneath so it's easier to line up and add. Okay, now I'm going to add it up. It's ready to combine when one of your variable terms is going to be eliminated. So my x's are opposite and I'm adding, so we're good. So I have 15y equals, when you add two negatives, they stay negative, negative 75. Divide by 15, y is equal to negative 5. So far, so good. Okay, I found y, so now I need to plug that in and find x. So you basically now have 3 equations to choose from. So that first equation before I tripled it, the bottom equation, or that equation after I tripled it, I'm just going to, this first equation that was typed here looks pretty easy. 2x plus 6y equals 16, negative 16. I'm going to plug in the negative 5 in for y. Now, when you multiply, sorry about that, 6 times negative 5, that makes a negative 30. So instead of writing plus negative 30, I'll just write negative 30. It'll be easier to do the algebra with less symbols everywhere. Divide by 2. Once again, you could algebraically verify by plugging it both in, making sure it equals negative 16 in the top equation, or negative 27, or type both original equations into Desmos and make sure they intersect at 7, negative 5. Okay, last one. Last one, another good candidate for elimination. So when we look here, those aren't going to eliminate if we add. If we look here, these aren't going to eliminate. Now, there are multiple ways you could approach this problem, but let's just look at the x terms, right? I could make the bottom one a 4x, but that's still, I like to add rather than subtract. So I need to make the bottom a negative 4x, because then it would eliminate with this 4x. So then I'm asking myself, what do I need to multiply 2 by to make this term a negative 4x? I need to multiply this by a negative 2. Then it'll make it opposite of this. There's a little bit of pre-thinking that goes into it. You have to think of like your factors. You have to think of your multiples, right? Okay. So top equation I did not, but we do not need to change. 4x minus y equals 11. Bottom equation, I had to pre-think, what can I multiply 2x by to make it opposite of this positive 4x? And I just multiplied it by negative 2. Now I need to multiply the whole equation by negative 2 to keep it equivalent. Negative 4x. Okay, negative 2 times negative 4y is positive 8y. And negative 2 times negative 26 is positive 52. Now when you add, those cancel out. A negative 1y with a positive 8y is 7y. And then you're adding here. 11 plus 52 is 63. Now we can easily solve for y. Y is 9. Okay. Now that we know y, we need to find x. Any equation will do. Let's do the top equation. Okay, so I have the top equation, 4x minus y equals 11. So I found y is 9, so I'll just plug it in. 4x minus 9 equals 11. The nice thing is just a plain old y. Sorry about that. So you don't have to multiply that. It's not like 3y or anything. So I'll just rewrite it without the parentheses. Add 9. 4x equals 20. X equals 5. And again, to check algebraically, boom, you could plug the 5 and the 9 into the top equation, make sure it equals 11, into the bottom equation before you multiplied to make sure it equals negative 26. Or you could type both into Desmos, graph it, and it should intersect at 5, 9. All right, guys, good luck.